You wrote a simple SQL query on a database and it takes 5 seconds to run this query. Then you add an index and suddenly it's 5 milliseconds. How is that possible? Why does having an index makes it so much faster? Let's open up database and see what's going on behind the scene. So when you run a query without an index, it will go one by one in each row and try to see if this query matches to this row, which is alright if you have around 10 or thousands of rows, but when it comes to millions or tens of millions of database, it becomes painfully slow. So without an index, it's O of n, but if it's with index, it's log of n. So think of indexing as an index of a textbook. When you want to go to a specific chapter, you look up the chapter page number and you directly go to that page number instead of going through starting from the page one. Indexing is similar. Indexing is basically creates another data structure that stores all the key and values of that row. So let's say if we create an email index on an email, it will take this email and its address and store it in that data structure. The data structure that is used for this is called B tree. It is basically a sorted balance tree that lets database skip over large chunks of data. So let's say if I want to go to this email again with abc@gmail.com, I already know that A will be on the left side, since in balance tree all the values on the left side are less than the mid value and the right side are the greater than the mid value. So if M is the mid value, then it will probably on the left side, A to L. Similarly, I will go down and I will find my condition which I am looking for. So this will allows me to skip large of data. I don't even have to check most of the data on the right side. This is how indexing works. Let's try to look this up using an example. As you can see, I have a database now here. I am working on PostgreSQL here. So let me try to show you how much data we have in the database right now. Okay, yeah. You can see it took 3 seconds and it had 10 million users rows in this. Now let me try to run this query where I need to specifically find a single user whose email is equal to this. Okay. It took 700 milliseconds. So inside the PostgreSQL, there are other optimization also like caching, but let's try it. It took 780 seconds almost. Now let us try to create an index on email column and see how much faster it is. Okay, great. It took 25 seconds to complete this. It depends on how much data it's there in your database. Now, let us retry to run the same query again. This one. You can see it took 94 milliseconds. Almost, it says almost 80 to 90% faster, and it can be sometimes larger also. Previously it was around 780 milliseconds, now it's 94 milliseconds. Indexing is not an all-out solution, it has some cons to it also. It will take additional storage in your databases to store that key value pairs in their data structure, and it might also slow down your databases also. So it is recommended to only add index on the columns that are most used by the users. It depends on your database which column that might be. To wrap it up, when your query is slow, it's often because the database is scanning the entire table. An index gives the database a shortcut, a pre-sorted map that lets it jump straight to the data it needs. Use them wisely and your query time can drop from seconds to milliseconds.